Hello, today it's time for another episode. We are here, a computer model of dark energy. Numerical model of dark energy has already been presented. Episode 3 and Episode 7 for entire galaxy. This has already been shown. This episode is optional. Why? I have already shown the dark energy model in program MathCAD 15. This episode is optional. Now, I will show you the same model, but in a different program. This is SMath. This program is free. SMath is very similar to MathCAD, MathCAD 15 and MathCAD Prime 10. The programming style is similar, with few differences. You will find out in a moment. This episode is optional. If you prefer another program, skip this episode. There will be different episodes for other programming languages. If you choose SMath, keep watching. I invite you to watch. Here are the online links to the files for all model versions. One link is enough to download the file, zip archive. It must be unpacked on your computer hard drive. After unpacking the file, the program directories will be available. The appropriate models are contained in the folders. One link is enough. I prepared several copies. If one service stops working, you should choose another one. Version for SMath. On the left, select the appropriate folder. SMath. On the right side, you needed to run the file with the dark energy model for the selected object. Let this be the tiered file. Model for Earth, dark energy 03. The program has been started. Here at the top is the file name, dark energy 03 Earth. We start with the basic variables. It's the basic parameters of this astronomical object, planets or the Sun. We need the light speed, the gravitational constant, the mass of the object. Here is the radius of the Earth, the acceleration of gravity of the surface of the Earth. Volume. This is the formula for the volume of a sphere. 4/3 pi times r to the third power. We use the standard volume equation. Average density of the planet. This is the ratio of a planet's mass to the planet's volume. Rho is here. You must declare the number of layers for the object. Layers. Selected layer parameters that will be calculated. You can set any number of layers. For example, it can be 100 layers, 1,000 layers, 1,000,000 layers. The number doesn't matter. I set 1,000 layers. This number can be changed. You can set it yourself. The radius increment is directly related to the number of layers. The radius increment, delta r, is the ratio of the planet's radius to the number of layers. He is about 6,000 meters, a little more than 6,000 meters. The single layer of the planet is about 6 kilometers thick. Variables are not complicated. These are the basic variables, the basic physical parameters. The listed parameters are quite enough to calculate the gravitational energy of an object. The equations to calculate gravitational energy are already known. This was shown in the previous episode. What's next? We are moving on. Remember what you need to calculate first. These are the basic physical parameters for a sphere as a function of radius. Below is the construction for calculating these parameters. The basic physical parameters what were shown in the previous episode. The first one is the radius. Here at the bottom, how to determine the radius of each solid. Surface area 4 times pi times r squared, surface of a sphere. Volume 4/3 pi times r to the third power. Mass. Mass is average density times volume. Gravitational acceleration on the surface of a sphere. Here is the equation. All the equations shown before are placed here. They operate in a loop and are calculated cyclically. From the first element to the last, Nmax, calculations will perform sequentially. First is R calculated. This is the radius of sphere number n. N times delta R. Delta R, its radius increment and was calculated earlier. Value about 6 kilometers. Surface area 4 times pi times r squared. Volume, another variable 4/3 pi times r to the third power. Mass is density times volume. Gravitational acceleration on the surface of sphere. The program should not lose calculation in the next step. The program should not forget variables and override values. Therefore, the program saves all variables under a different name. A new name for the radius here. For the row n, the value of the variable r was rewritten. Similarly, for the surface area. For the row n, the value of the variable s was rewritten. Similarly for volume. Similarly for mass. Similarly for the gravitational acceleration. For row n, the value of variable a was rewritten. Here calculated. The calculated values for all variables are shown on the right. Numerical model, computer model. The parameters of the primitives or spheres have been calculated. These parameters allow for further construction of the model. Dark energy model to calculate its value. What's next?
Umożliwiająca obliczenie ciemnej energii. No to popatrzmy dalej. No a dalej mamy
calculations for layers. We will calculate the volume of layers and the mass of layers.
Masę dla tej właśnie warstwy, dla tego shella.
The volume of a single layer is calculated here. It is the volume of a sphere n minus the volume of the sphere n minus 1. A sphere one size smaller than the previous one. The difference between these values is the volume of a layer. We performed similar calculation to determine the layer mass. The mass of a single layer is the mass of the ball n minus the mass of the ball n minus 1. The ball one size smaller than the previous one. The difference between two values is the mass of the layer. We remember how it was explained. A ball of size n minus a ball one size smaller, n minus 1. For mass, it's similar. These equations are applied right here, in this loop. Numerical calculations are shown on the right. It is worth noting that these equations are in symbolic forms. This is the form of equations we write in notebooks. The natural form of physical equations. Markup allows to use symbolic equations. Just one look is enough. You immediately know what is written.
Wiadomo, o co chodzi od razu niejako, tak? Z marszu wiadomo, jak równanie wygląda i o co tutaj chodzi.
Parameters for the layers have been calculated. The next is force.
Obliczone. Musimy obliczyć
The gravitational
siłę.
force for the layers.
Na dole jest
Here,
obliczona siła
the gravitational force is calculated
grawitacyjna, idąc
from the
od
bottom
dołu
to the
do
top,
góry, czyli
from the
od
object's
jądra
core
obiektu
to
aż
the
do
surface.
powierzchni obiektu. Zobaczmy.
This was explained in the previous
Na
episode.
poprzednim odcinku, że
The gravitational acceleration at the object's surface is marked in blue on the surface of internal ball. The gravitational force is the mass of the layer multiplied by the gravitational acceleration.
Masa tej
Mass of layer calculated for larger sphere minus smaller sphere. Difference of both masses. Force of gravity consists of two variables. First is the mass of the layer. Second variable is the gravitational acceleration, internal sphere. This is the gravitational force for sequent layers.
I zwróćcie uwagę,
It is worth noting that all the parameters have already been calculated. Parameters necessary to determine the force of gravity.
a zatem
Here,
o tutaj
under the loop,
pętlą
the variable for mass.
mamy masę.
It is similar for the acceleration of gravity.
Podobnie z przyspieszeniem
However,
grawitacyjnym,
the acceleration must be chosen for a sphere one size smaller,
graf
n-1. This is very
A
important.
przyjmuje wartość właśnie a graf n-1.
The force of gravity is calculated by simply multiplying both variables.
Masa razy przyspieszenie grawitacyjne. I tu
Calculations.
po prawej stronie jest
This is the gravitational force for the sequent layers,
kolejnych warstw,
except the first layer,
oprócz tej
of
pierwszej
course.
oczywiście.
The first position is
Na pierwszej
empty.
pozycji stoi 0.
The calculations are performed from the center of the object to the surface of the object.
Aż do jego powierzchni.
Here are the previous calculations, and here at the bottom are the next ones. Counting from the surface, we will add up the force values for sequent layers, because the values for the sequent layers should be added together.
Ta ostatnia
The current layer is summed with the previous layer, from the surface of an object to its center.
jest sumowana z jeszcze wcześniejszą. Tak? I tak idzie od góry do dołu, od powierzchni aż do środka. I tutaj mamy...
Here is the realization. The loop starts from the value nmax minus 1 and run to the first element,
Aż do pierwszego, czyli od
from
powierzchni
the surface to the center. Simple summation operation.
to jest po prostu zwykłe sumowanie. Gdzie
The
siła
gravitational
grawitacyjna
force
tej
for
warstwy
layer
jest to
n
siła
is the
grawitacyjna
gravitational
tej
force
n
of
tej
that
warstwy,
layer
dodać
n
siłę
plus the
grawitacyjną
gravitational
warstwy
force
o
of
jeden
the
większy,
layer one size
ponieważ ta
larger
siła grawitacyjna
n
dla
plus
warstwy o
1.
jeden
A layer one
większy
size larger already
zawiera już w
contains
sobie
all the
wszystkie
previous
jakby
layers.
poprzednie, wcześniejsze,
Layers we added
powyższe
earlier.
warstwy sumowane. Tak? I tak sumuje to wszystko i mamy rzeczywistą wartość
Here is
siły
calculated
na
the
konkretnym
actual
poziomie,
force
na
value.
konkretnej warstwie
Values are recorded in the
obliczonej,
table.
tak? I tutaj w tabelce są oczywiście wartości numeryczne podane.
We
Pamiętamy,
remember how it was explained.
jak to obliczyć, tak?
Now we know the gravitational force inside an object. Now it's possible to calculate the internal gravity pressure value.
Właśnie dla konkretnej warstwy, gdzie ciśnienie
Gravity
konkretnej
pressure of
warstwy,
layer is the ratio of gravitational force to surface
siły
area.
grawitacyjnej dla tej warstwy podzielonej na pole
The
powierzchni.
gravitational
Tego, co
force
pod spodem,
between
czyli
the selected layer and the surface of a sphere one size smaller, n-1.
czyli
The
pole
sphere is
powierzchni
located directly under this layer.
dana warstwa,
This layer is
jak
located
leży i
directly
naciska,
on the surface and press against that
podzielona na
surface.
to pole powierzchni daje nam ciśnienie.
Gravity
tej
pressure
średniej
is
ciśnienie tej
generated, the
właśnie
average pressure for
warstwy.
layers.
No i
Here
mamy
under is similar
tutaj
constructions
pod spodem
as before.
podobna konstrukcja jak wcześniej, No i mamy
The loop
wędkę
iterates from the
od
surface
powierzchni
nmax
do
to the second layer from the
do
center.
drugiej, przedostatniej jakby wewnętrznej warstwy, gdzie pole
Surface area of the sphere
danego
one size
obiektu
smaller,
to
n
jest
minus
pole
1,
kuli
the smaller one.
n-1, tej mniejszej. Mamy siłę grawitacyjną.
Here is the gravitational force for layer n.
Podstawiam sobie pod
F
literkę
is the force symbol.
prościej to zrobić. No i
Below is the calculated
obliczone
pressure.
ciśnienie.
Here,
Ciśnienie jest to ta siła podzielone na
the
P.
pressure is the force divided by the surface area, surface of the sphere in this case.
Żeby się już nie myliło,
New
press
variable
N,
saves the
tak, to właśnie
calculated
obliczone
result
ciśnienie.
for current iteration.
A ta pierwsza
The first
warstwa,
layer
to
could
zobaczcie,
not
press
be
1
calculated.
podstawione jest press 2,
Here,
czyli dla
the variable
tego centrum
press
tej
1
wewnętrznej kuli,
takes
no
the
to
value of the variable press 2. This problem was solved in easy way. There will be a small imprecision of the result. It is really small. This center layer, or rather the central ball, core cannot be calculated in any other way. That is why I set the value of the layer one size larger, value of second layer counting from the center. There are no significant difference between these layers. For a large number of layers, the radius increment delta R will decrease. Gravitational pressure has been calculated. Gravitational energy is coming close. On the right, energy is pressure times volume. All the necessary parameters were calculated earlier, pressure and volume for the layers. Now, we need to calculate the gravitational energy for these layers, shown here. The gravitational energy for all layers will be calculated. The sum of the layer values gives the total result. Gravitational energy for object. Gravitational energy is equal of dark energy, but has a minus sign. Here under, similar constructions as before for gravitational energy. From the surface, nmax, to the center of the object.
Do środka, do centrum obiektu. Objętość.
The volume variable takes the appropriate value from the table V shell. The pressure variable takes the appropriate value from the table press. Energy is pressure times volume.
Ciśnienie razy objętość danej warstwy. No i mamy, nazwałem zmienną
Variable a graph saves the result.
Dla konkretnej warstwy jest to właśnie podstawiane tutaj. A tutaj
Notice, here it's the sum of all layers, from the first layer to the last layer, nmax. Summation for 1000 layers. All the elements are added together for total value, the value of gravitational energy.
I mamy całkowity wynik energii grawitacyjnej tutaj. A poniżej
Below is dark energy.
Ciemna energia jest to energia
Gravitational energy with a minus sign. Exactly the same value, but with a minus sign. Below is equation for mass equivalent for gravitational energy. I calculated for curiosity. We remember the most famous formula in the world. After rearranging the equation, the mass is determined, rather the mass equivalent. What mass value corresponds to this dark energy? That mass is being absorbed by the object at any moment, in 1 second.
Niejako taki ekwiwalent masy dla tak obliczonej ciemnej energii jest zużywany w każdej sekundzie. I teraz.
Below is the mass of the planet. It is declared at the beginning of the file. Input data. In this case, it is the mass of the Earth. The variable proc1 is 1% of the mass. 1% of Earth's mass.
To jest właśnie 1% masy planety.
The last variable is the percentage coefficient. Is the percentage of the dark mass to the mass of the object. For Earth, of course. Yes. How much of the Earth's mass is absorbed in the form of dark energy or dark mass? Percentage coefficient help us better understand this process. All results are presented in numerical form and we can browse them. But why make life so difficult? It is better to put the numerical data on a graph. Just take a look at the chart.
Dane numeryczne zobaczyć na wykresie. Wrzucamy to wszystko zatem na wykresy i zobaczmy, jak to wygląda.
First graph, gravitational force as a function of radius.
Siły grawitacyjnej.
Below is the graph of gravitational energy, the most significant. A graph of gravitational pressure.
Oba wykresy są dla ciśnienia pokazane, przy czym jeden jest pokazany w pełnej skali, ponieważ oś Y nie jest logarytmiczna, dlatego taki pik powstał tutaj na całą, zajął dużo miejsca, tak? I już nie widać tego, co jest na osi X jakby dalej, więc na dole pokazałem jakby takie zbliżenie. Jest to samo, tylko tak rozciągnięte troszeczkę to kolanko funkcji tutaj na dole, zobaczcie.
A graph of the surface of layers.
Pola powierzchni w funkcji promienia i pod
A
spodem
graph of the volume of layers.
objętości tych warstw, tak? Też w funkcji promienia.
A graph of the mass of layers. Calculations and graphs for Earth. The same scheme can be used for any object, for any planet or sun or star or moon.
Dowolnej gwiazdy czy księżyca, jakiegokolwiek.
Even for a black hole, it can be calculated. We don't know what is inside a black hole, of course. If we know the mass of the black hole, volume, surface, and all necessary parameters, then we can try. There is an assumption that the density distributions should be constant inside the black hole. We don't know if this is true. If yes, then the calculations should be correct even for a black hole. I made example file for a black hole. I'll show you the results in a moment. Sun. Here are the parameters of the sun. Here are the results of the calculations. Mercury. Here are the parameters. Calculation results. Venus. Here are the parameters. Calculation results. Calculation for Earth have already been shown. Next is the Mars.
I tutaj mamy wyniki dla Marsa.
Next is Jupiter.
No i wyniki.
Saturn. Uranium. Neptune. Let's look at the results for the black hole.
wyniki dla
Just for
Sagittariusa
curiosity.
czarnej dziury w centrum
Result for the
mlecznej.
object Sagittarius A.
To są parametry.
This black hole is located in the center of the Milky Way. Here are the parameters and the results. But remember, this calculation is conditionally correct. I created this file because it's possible. Nobody knows what is inside a black hole. What is the structure of density there? The truth is the interior structure is not very important. Surface area, volume, radius, and mass are important. Calculations should be correct if density distribution inside the object is constant. If not, then the calculations will not be correct.
Dla wnętrza czarnej dziury, no to te obliczenia nie będą poprawne, będą dalekie od poprawności. No ale
So, let's check it out. We won't lose anything.
Zobaczyć, jak to by było dla czarnej dziury.
What is the result for the black hole? I haven't simulated the moons, but that's a possibility. We can do calculations for the moons, for all the moons. I did not run simulation for Pluto because it is not allowed. The Astronomical Union has ruled out Pluto. Any discussion on this topic is strictly forbidden. I am joking, of course. Pluto can also be simulated. This is how we calculated the dark energy for an object, for many astronomical objects. Dark energy is flowing in. It's hard to calculate dark energy directly. The indirect method is much easier. You can calculate the gravitational energy inside the object. Gravitational energy is the equivalent of dark energy. What is inside is the equivalent of what is outside. It's much easier this way. That's exactly the simple method I was talking about. We have solution for dark energy, and that is the most important thing. Bye!
Na razie, cześć!